In this video, we are going to talk about the integrals of functions that are either even or odd, and what kinds of patterns and observations can we make that might simplify some problems for us. So recall, an even function is a function where f of negative x is equal to f of positive x for every choice of x. So when you have an even function, those functions are symmetric about the y-axis. And if you have an odd function, odd functions, f of negative x is the negative of f of x. Those functions are symmetric about the origin. If you look at those, if you make those observations, then if you have an even function, if f is an even function, and it's integrable on a closed interval from a to negative a, or from negative a to a, then this integral here is 2 times the integral from 0 to a. And similarly, if you have an odd function, the integral from negative a to a is just going to be 0. And why would that just be 0? Well, it's just going to be 0 for the odd function because your stuff here is going to cancel out exactly with the stuff there. And for an even function, you have something that doubles, because if we're looking at these areas, these two areas are the same if we're going from negative a to a. So we could just go from 0 to a and double it because the other piece is the mirror image. Here this is a mirror image, but a negative mirror image of this, and so that's why it zeroes out. So this one becomes twice the integral from 0 to a. This is just going to cancel out if you have an odd function. And yeah, so this should be a closed interval from negative a to a. Great. So let's look at an example. Here, if I want to integrate tangent of x dx from negative pi over 4 to pi over 4, then I can observe that the tangent function, that is an odd function. Its graph is symmetric about the origin. And so when I go from negative pi over 4 to positive pi over 4, the area below the axis and the area above the axis are going to be exactly the same. And so this integral is 0. So I can make the observation about the oddness of tangent, and because these limits are negatives of each other, I know that the areas are just going to cancel out. Great. And if I wanted to integrate from negative pi over 4 to positive pi over 4, let's say I wanted to integrate cosine x dx. That cosine graph I could observe is symmetric about the y-axis, and so this is going to be equal to 2 times the integral from 0 to pi over 4 of cosine x dx. I won't, well, let's go ahead and finish that up. So cosine integrates to sine. So we have 2 times the sine of pi over 4 is root 2 over 2. The sine of 0 is 0. So we end up with just the square root of 2. And that's what we have. Great. Thanks for taking the time to learn Calculus 1. I hope to see you again.